So we now begin a discussion of precipitation and atmospheric processes in general. And in the hydrological cycle, there's no real necessary place to start. We could start by talking about runoff or evapotranspiration, but we're going to start with precipitation, largely because it is a first order control on the hydrological regime of an area. So what is precipitation exactly? I'll give you one formal definition. Precipitation is the deposition of water that's formed in the atmosphere on Earth's surface. So deposition of water formed in Earth's atmosphere on Earth's surface. So this could be something like drizzle, small droplets with fine particle sizes, maybe between 0.1 and half a millimeter. It could be rain, which is coming as a liquid, typically above half a millimeter in size. It could be snow, which are solid hexagonal crystals that are typically agglomerated together. Could be hail, which are big ice chunks, or sleet, small pellets or grains of ice. There's another type of precipitation that you should be aware of, and that's called the occult precipitation. It does not have anything to do with witchcraft, but occult precipitation is precipitation that you may not necessarily see falling from the sky. That's why it has the word occult, or hidden, behind it. And this is the capture of fog or mist by the leaves or branches of trees and other vegetation, by foliage. So that's what occult precipitation is. Now, there's three general terms that you'll hear over and over when it comes to precipitation, and that is intensity, duration, and amount. And these have particular meanings in hydrology, so I'm just going to define these for you here. The intensity is the rate per unit time at which the precipitation is arriving. For example, millimeters per hour. And I'm going to emphasize again with the star that even though this has dimensions of length per time, this is not a particle velocity. It's not the speed at which an individual snowflake or raindrop is falling. Rather, it's the flux. So it's the equivalent thickness spread out over Earth's surface per time. Duration is pretty simply, it's just the length of time during which the precipitation is falling. So the length of time of precipitation. Then the amount of precipitation, which has the dimensions of length, is going to be equal to the average intensity of precipitation times the duration, the overall length of time over which you're measuring it. So the intensity may go up and down through time. If you take the average over that time and then multiply it by the length of time over which you're calculating precipitation, you'll get the amount of precipitation.